Hello and welcome to maybe the sixth class on haloalkanes. And before we start haloalkanes, the hardcore organic chemistry with mechanisms, I would like to discuss the doubts on electrochemistry raised by Mr. Rudra, which I took a long time. I didn't get time to look into that. But these two are very good doubts. Good morning, Samidha. You are late by 4 minutes. कोई बात नहीं, कोई बात नहीं. हमारा एक स्लोगन है बेटर लेट देन नेवर. गुड मॉर्निंग.
Good morning, sir.
Now here is a very good question which was raised by Mr. Rudra. Plotting 1 by lambda molar conductivity against C into lambda molar for aqueous solutions of a monobasic acid HA of a monobasic acid HX resulted in a straight line with y-axis intercept P and slope S. The ratio P by S is what? Now see, it seems from this question that the slope has to be positive because we had a graph of lambda m versus root C for strong electrolytes. For weak electrolytes, even if it is strong electrolytes, graph may not be linear, but 1 by lambda versus root C will not be giving negative slope. But this is 1 by lambda. As lambda increases with decrease in concentration, that means the slope will be negative. But 1 by lambda, if lambda decreases, 1 by lambda increases. So with decrease in concentration, 1 by lambda also decreases. Conversely, with increase in concentration, 1 by lambda increases. So this is a positive slope, it seems. But we had not discussed this graph, which we are discussing for the first time. And we know that for certain concentration region, at a low concentration region, the graph for weak acids, weak electrolytes are linear. But as the concentration becomes less, dilution becomes more, then it suddenly takes a curvature and the slope increases drastically. So that is, but during the linear region, if we analyze for a weak acid like acetic acid or any monobasic weak acid, then what will be the nature of the graph? Not lambda m versus C or root C, but 1 by lambda m against C lambda m. Lambda m is also in the abscissa. I mean x-axis. This is y-axis coordinate. Am I correct?
Yes, sir.
Now you can, it looks like this will give you a graph with a positive intercept and also positive slope. And it was looking to the slope is coming this after derivation and the intercept is coming this. See, it's very simple because the conductance ratio is the degree of dissociation of a weak acid or weak electrolyte is lambda m by lambda naught m. And for weak acid, Ka is C alpha square minus 1 divided by 1 minus alpha. We keep alpha in the denominator. Don't neglect it. So putting the conductance ratio and then simplifying and dividing by lambda m, we get ultimately 1 by lambda. Our interest is to bring the equation in the form of 1 by lambda m. So when we bring, it looks like this. And I will be sending you. Then we separate, take this portion to the right side, which is constant. This is the intercept. And since the x coordinate is c lambda m, it has asked, so we keep it as a variable and the other constants as the slope. So we found slope is this and the intercept is this. So take the ratio. There is a cancellation of 1 lambda naught and we get Ka into lambda naught m. So that, is bit A. You understood? Master Rudra?
Yes, sir. Yes, sir.
Okay, but the other one is not that very interesting, but maybe interesting. Remember, now let me read out for the benefit of Miss Samidha. M2 plus is radioactive. If M2 plus is radioactive with alpha emission, then the correct order of radioactivity of the following substances is this: 1 gram MO, the metal oxide, 1 gram metal sulfate, 1 gram metal chloride, 1 gram metal sulfide. It seems it is a divalent metal. Of course, it is given divalent M2 plus. So the nuclear activity, decay, alpha ho ya beta ho, whatever, is a nuclear phenomenon. Nothing to do with the electrons present outside. Whether it is 2 plus or 3 plus or 5 plus, we don't bother. How many number of atoms or ions are there? That will be giving you the rate minus dNt by dt is equal to K, or sometimes it is called lambda, K into Nt, number of atoms. I told you that while solving a problem on radioactivity, there is no concentration, there is number of atoms, Nt. So we have to convert this into number of atoms by just dividing the molar mass. Supposing this is x plus 16, this is x plus 96, x plus 71, x plus 32. And if you do that, and since the one which has a lower molar mass will have a larger number of moles. So one has a larger number of moles. X is common. We see the number of moles is greater means number of atoms is greater. The Na factor has to be multiplied. So accordingly, one will have most number of atoms. So the nuclear rate of decay is maximum, followed by, followed by 4, x plus 32, followed by x plus 71, that is 3, followed by 2, x plus 96. So the correct answer is 3. Got it?
Yes, sir.
So its mass is 1 gram because it's not alone. It is with its partner, negative partner. So we have to find the number of atoms or number of ions. Doesn't matter whether it is 2 plus or 3 plus. So with mole concept idea, we get the number of atoms or ions, and then more the number of atoms, more is the rate of decay. Got it?
Yes, sir.
Now back to our today's organic program. We were left with elimination mechanisms. If Samita, you had already watched last time, you perhaps overslept. Am I correct?
Yes, sir.
कोई बात नहीं. Have you got the time to watch the video?
Yes, sir.
Okay. We had completed E2, which is the dominant mechanism for the alkyl halides if elimination is the measure product, that is for 3 degree and 2 degree. And we have seen E1 in alkyl halides, E1 never happens for major products. When elimination is the minor product, when you are using a weak base solvolysis with a 3 degree halide, because that goes via carbocation, 3 degree halide. The weak base doesn't have a power to abstract a beta proton. In that case, carbocation will be formed, since their solvolysis reactions are usually polar solvents like alcohol, water. So carbocation हो जाता है, तो water immediately joins to form a protonated alcohol, then deprotonation will produce the neutral alcohol. But water also can have some power to abstract a beta proton. So there will be some minor products, maybe 15%, maybe 10% of elimination product. Undoubtedly, that has been found. And that by E1 mechanism. But alcohols, we discussed that alcohols, excepting ethanol, all other alcohols, they love to go via carbocation and their rearrangements. So E1 mechanism operates there in alcohols, dehydration of alcohols to give you alkenes. We are studying E1 mechanism, of course, in the context of alkyl halides, but other aspects of E1, E2, we have to do that at this phase, at this point of time. Now comes E1CB. Elimination continues. This CB stands for conjugate base. And 1 stands for first order. So what happens? It is a two-step process like E1, but the primary requirement is there must be a EWG in the beta position. And this leaving group, the other one, is not alkyl halide. It has to be a very tough leaving group which usually will not be subjected to any elimination reaction or substitution reaction like OME. So between OME minus and Me minus, OME minus is a relatively weaker base and a relatively better leaving group. But both are strong bases. They don't leave. But in this situation, EWG, supposing you have here NO2 or CN, I will give you some examples, or NO2, like that. In that case, what happens? In the rate determining step, the base that you use, strong base that you use, will first abstract the beta proton to form a stable carbanion. That is the conjugate base. That is why we say E1CB conjugate base. And the one elimination which was impossible had there been no EWG, now the mechanism runs with a different route. Carbanion is formed first. Since carbanions are stronger bases than alkoxide ions, in that case, in the next step, which is fast, this is slow. This is slow step. Hence, it is first order. Then this is fast. Then this comes here and this goes. And we get. Oh, I'm so sorry. I stole something, but I did something. So we get this compound. You understood?
Yes, sir.
Yes,
And
sir.
Yes. The examples that I would like to give, only one example we can one or two examples we can give. Now see, if example we can give, supposing we have a compound like this. This is a benzoyl group, which is highly electron withdrawing. C double bond O, again, there is a conjugation with phenyl. So when that is in the beta position and we are taking this compound, it was found that the reaction goes with E1CB step and alcoholic OH. Then this is the slow step to give you the carbanion. But the primary requirement is there should be a strong minus, EWG at the beta position. So you have this one. And the other leaving group should be preferably a strong base. If you take a weak base like chloride, bromide, iodide, then the mechanism will not favor this because they will leave fast. Either to produce carbocation E1 or simultaneously to produce the product E by E2. So we have deliberately chosen the other living group, not halide. Although we are studying the chapter halide, then this will come, and relatively very better living group is OMe minus. So this is a first step, and we get PH C double bond O, CH double bond C Me. It would H rohigala baki. H. So this is the product, and the mechanism is E1CB, and other products are also there. There are umpteen number of cases I can cite, but I don't have time. We have to proceed. Then comes the SYN elimination. We had seen 4. And in SYN elimination, there are 2 types. The important SYN elimination is EI, that is internal or intramolecular. There is another another SYN elimination, which but let us talk. This involves a cyclic TS. Cyclic TS. And here it doesn't involve another. This is not called EI. It is simply SYN elimination. SYN without cyclic TS. So first, the most important EI you will take, EI internal intramolecular. So the examples are, pyrolysis means strong heating of xanthate esters. I'll tell you what. This is called the Chugev reaction. Chugev reaction. Then you have 3-degree amine oxides. This is called the Cope reaction. The Chugev reaction, Cope reaction, and acetates. Undergo EI elimination. Now what happens, let me directly tell you what happens. Then I will tell you first the Chugev. xanthate esters. I'll tell you how xanthate esters are prepared from alcohols, just like OTS. The tosylate living group is prepared from alcohol using tosyl chloride or paratoluene sulfonyl chloride. Esterification is done to make it OTS. Then that is subjected to elimination because OTS minus is a good living group. So let me first tell you what is seen in elimination. This is the xanthate esters. There are two sulfur. One is a double bond S, one is a single bond SME, xanthate esters. And we will take two chiral centers deliberately. Supposing I will make it TBU, dot butyl. Deliberately, I'm taking TBU because actually there are two aspects, not only SYN, but also Hoffmann. It will not, if I make it CH3, then it will be kept here, CHHH, and the major product will be the anti-Surjev or less substituted alkene. So to show you the mechanism, I have not kept any beta hydrogen in the alpha position. Yes, there is a beta hydrogen here, but if it is CH3, then it will be less branched alkene, anti-Surjev or Hoffmann product will be formed. And this is supposing say T. There are two chiral centers. Now what will happen when you heat it to 200 degrees Celsius? Then there will be in a cyclic, even before heating, it will remain in the antiform because this is the eclipse form which is unstable, but it will come before the reaction. Then this bond will break. I'm showing in a different color. This bond will come here, this bond will come here, and this bond will come here. So that MESH will be formed and a neutral carbonyl sulfide will be formed and a double bond will be formed. And both the living groups are on the same side. That is why it is called SYN elimination. Why I? SYN. But it is named as EI because intramolecular and internal. There is no base to abstract a beta proton. There is no added base, khali pyrolysis. So this is EI plus carbonyl sulfide plus methyl mercaptan or methane thiol. Got it?
Yes,
sir.
sir.
Just write down NB. The Hoffmann product here is the major product here. ଏଠି ମୁଁ ଜାଣିକିରି ହଫମ୍ୟାନ୍ ପ୍ରଡକ୍ଟ ରଖିଲିନି ଖାଲି ଦେଖେଇବା ପାଇଁ ସାଇକ୍ଲିକ୍ ମେକାନିଜମଟା এটা TS টা. This is the TS, not that there is any intermediate formed. Then similarly, N-amine oxide I am showing you and how it is prepared. I will give you this. Now see, let me make it little bigger so that you will know what are the steps to make xanthate esters. Now you take the alcohol, then use a strong base like hydride, sodium hydride, to produce the alkoxide ion, and then treat it with carbon disulfide. So this will attack the carbon and there will be polarization to produce this compound. This intermediate S minus. Then treat it with methyl halide or any alkyl halide, usually methyl halide. Then S minus is a very good nucleophile, being a soft base, it will attack. I minus will go. So SME. So in three steps. First, it is converted to alkoxide, then carbon disulfide to form a xanthate salt, not ester. Then with methyl iodide, it forms a xanthate ester. This is xanthic acid, SH. And this is the methyl ester of xanthic acid, xanthate ester. Then you perform the. So if you want two things, SYN elimination as well as Hoffmann, then you have to convert alcohol into xanthate esters. Not that xanthate esters are available in the market, but you have to design the synthesis to get xanthate esters and then heat it to get your desired Hoffmann product or major product and as well the SYN. You can yourself find out if we get this alkene. See, if you are getting this alkene, I'm coming back to my page. If you are getting this alkene, and this will be E alkene, then if we make a switch in one configuration so that we get another diastereomer of this molecule, then you will get Z alkene by the same EI mechanism. Got it, Ms. Amida?
Yes, sir.
Now I will just highlight with the book the other SYN mechanism. Yeah. Another thing is N-amine oxide, the Cope reaction. That is important. The same. You can convert it to now same. You convert a 3-degree amine into its oxide O minus. I'm not showing 3 lone pairs. And here is one chiral center, R1 say R2, and there must be a beta hydrogen. Here also you get Hoffmann product. I'm avoiding making it R3, R4. I'm showing you the mechanism. And then when you heat it, this is N-amine oxide, 80 to 100, little lower temperature is required. This is a tertiary amine, NR2, and one of the groups has a beta hydrogen. I have not shown its CH3 here because if this is alpha, this is beta. So if this is alpha, this is beta with respect to this. So I'm not showing any other group here so that if it is, CH2, CH3, then there is a beta that will come to form CH2, CH3. Then that will form a less substituted alkene. That is what is that happens here in both Cope and Chugev. But I am showing you the mechanism. What happens when we heat, then same thing will happen. No. It will neutralize. It will neutralize this, and then this will come here to abstract the proton, so that you will form one compound. This is detached, so you get your alkene R3, R4 and R1, R2. But the other compound is NR2OH, hydroxylamine. It is dialkyl hydroxylamine is the other product. So this is Cope reaction, N-amine oxide. You can prepare N-amine oxide by taking R3N, where one of the R will have a beta hydrogen, at least 2 carbon atoms, with MCPBA. What is MCPBA? Rudra?
Sir,
What?
this is oxygen lagi ki bond.
Mr. Gigi, you are forgetting that this is a fantastic compound reagent to make peroxides or epoxy linkage, metachloroperoxybenzoic acid. I have already told you during alkenes, when we take oxygen and silver heat to make epoxide or alkene oxide, instead of that, nowadays for inserting oxygen, we are using metachloroperoxybenzoic acid. Here is the peroxy linkage. So this is used very often to make oxygen insertion. So you can easily prepare, oh sorry, plus minus. And then you can carry out thermal pyrolysis, what we have already known. Then acetates. You can convert any alcohol to the acetate by treating with acetyl chloride or acetic acid, making ester, so that also is a very good substrate for the SYN or EI elimination. You must know for the advanced program. So this is the acetate which we have prepared from alcohol. This is a alcohol containing beta hydrogen. Same thing I am writing to avoid any confusion about the mechanism. So when you heat, this is acetate. Then what will happen? Same thing will happen. This will come and this will go. And this pi bond will break. Somebody has to take the beta proton internally. So what will be formed? What is the other product? Samida, what is the other product? Yes.
Acetic acid.
Acetic acid. Double bond was here. Now double bond is here. OH was here. O something was here. Now OH is here. So you get acetic acid as the other elimination product. The living product. So we are interested in alkene. So this is acetates. Xanthate esters, N-amine oxide, 3-degree N-amine oxide, and acetates. They, on heating, if they undergo elimination, they do so by EI internal mechanism. Then I will talk about Hoffmann elimination. There is another case of SYN elimination, which will not involve cyclic transition state. Now see, I'm taking di-tert-butyl. Tert-butyl groups are on both the carbons that will be having a double bond now. This is a trio compound. And if you bring the anti-periplanar condition, that is E2 condition, tert-butyl groups will come to the Gauss position. Be the steric strain, the steric hindrance, the van der Waals strain will be very, very high. Therefore, that makes the transition state very unstable. So in that case, it prefers to eliminate by SYN mechanism. So this is trio. Trio and erythro gives the same compound. That's the beauty. Trio does by SYN, it's not called EI, by SYN elimination. And erythro as usual, in the anti-periplanar E2 mode, you have tert-butyl also trans. So as such, erythro should have given trans-alkene by E2, but trio also gives trans-alkene by the other mechanism, SYN. I'll be sending this. Then we'll talk about Hoffmann elimination. This is the elimination which I think I have covered here. No. Somewhere, what did I do that? No. Anyway, କୋଉଠି ଗୋଟେ ଅଲଗା ଜାଗାରେ ଅଛି. The other one is Hoffmann elimination, fifth one. . where you get anti-Sadzev product. Anti-Sadzev product. So there are most important among them is you know, heating of quaternary ammonium hydroxides. Now, how we do hydroxides? Yeah. So we do process we do by Hoffmann exhaustive methylation process. One of the methods. Supposing you are given a 1 degree amine and sorry, you are 2 degree amine. Sorry, 1 degree amine. I'm so sorry. Amine is known from NH to NHN, not from C. So you are given sec butyl amine, which is a 1 degree amine. Remember, because we will study amines in details. Is a primary amine, but sec butyl amine, amine HA. We want double bond here as the absolute product. কিন্তু আমি যদি এটি ক্লোরিন নবা কি ব্রোমিন নবা আমি মেজর প্রডক্ট পাইবা বিউট 2 ইন নট বিউট 1 ইন আমি চাହୁଛେ বিউট 1 ইন পাଇବା ପାଇଁ ତେଣୁ ଆମିନରୁ ଷ୍ଟାର୍ଟ କର ଆମିନକୁ କ'ଣ କର ଅବଶ୍ୟ ଆମିନ ପୂର୍ବରୁ ଏଠି Cl ଥିଲା ତ ଏକ୍ସେସ୍ ଅଫ୍ ଏଇ ଆମୋନିଆ ଦେଲେ ୟୁ ହାଭ୍ ଗଟ୍ ପ୍ରାଇମେରୀ ଆମିନ as the major product तुम पाइଛ सेपरेट कर देइଛ सो प्राइमरी अमीन तुम नेइछ तापरे एक्सेस दियो CH3I एक्सेस सो दैट गोटे परे गोटे सब्स्टिट्यूशन ही चलिबो अल्टीमेटली 3 मोल्स लागिबो टू प्रोड्यूस N CH3 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 plus we want quaternary ammonium hydroxide बर्तमान ये आयोडाइड रहा मु थर्ड स्टेप पर कहूँ प्रथमे गोटे मेथिल जीव सी थ्री पुणी लोन पेयर आसो सी आउ गोटे मेथिल आसो देन आउ गोटे लोन हाइड्रोजेन ना तेणु से लोन पेयरटा आउ गोटे अटाक कर सो दैट इट विल बी परमानेंट सॉल्ट दिस इज ए 4 डिग्री अमोनियम सॉल्ट आम तैयारी कले तापरे ताकू सिल्वर हाइड्रोक्साइड देले से I माइनस टा पड़ेबो सिल्वर ताकू नहीं सिल्वर आयोडाइड येलो प्रेसिपिटेट हो वी गेट इट्स करेस्पॉन्डिंग हाइड्रोक्साइड नो दीज थिंग्स आर required only for the advanced level not for and silver added पड़ेगा यही मुझे हेडिंग टा लिखी एटारी क्वाटरनरी और 4 डिग्री अमोनियम हाइड्रोक्साइड एटा कला परे सिंपली ताकू हिट करिवो एटा को हिट कले कोन हबो ना जेहेतु एटा गोटे एते बल्की ग्रुप टा you know the OH minus which is already there in that molecule will act as the base not to enter into this hindered position sterically hindered position instead this is sterically less hindered position so it will attack here now see what happens it attacks here then this goes as a neutral 3 degree amine so 3 degree amine रो preparation रो भी हमें पढ़िबा एटा मेकानिज्म रे कले एवं 3 डिग्री अमीन रो प्रिपरेशन तो अमीन्स पढ़िबा सो दैट एटा एटा आसला एटा सॉरी एंड एटा ठीक गला आई एम सो सॉरी ये OH माइनस एटा H प्लस को कामुडी नेला and then this bond sigma bond turns into a pi bond and this carbon nitrogen bond breaks to form a neutral amine so you get major product as CH2 this plus buy one get one free you get a 3 degree amine as the other product and a Hoffmann alkene or less substituted alkene anti-Sadzev alkene you got it this is another, and this is one important Hoffman product which you get in absolute abundance. Got it?
Yes, sir.
Now I will be wanting to test you. Supposing I will give this directly, ମୁଁ ଦେଇ ଦଉଛି এই कंपाउंड को जदि हिट करा जाए तमे मेजर पेयरटा लेख, माइनर पेयरटा पछरे लेखिबो. गोटे आईआईटी एडवांस रे पढ़िथिला फ्यू इयर्स बिफोर. एथिरे मेजर प्रोडक्ट पेयरटा गोटे 3 डिग्री अमीन हबो, गोटे अल्किन हबो, सेटा कोटा हबो? मते टिके रुद्र मने पकेइबो. ए समिता, डू यू हैव ए क्लास at what time, or coaching or whatever? What time you are leaving?
So whenever the class ends.
आज को स्कूल नहीं?
No, sir.
So we are planning to extend today's class to finish the haloalkanes, so that next time we will be starting haloarenes. Okay?
Yes, sir.
Yes.
लिखिसारिलेଣି? कौन हबो?
सर एटार भी या पूर्वटा परिका सेम जगारो हाइड्रोजन एक्सेप्ट.
हम्म?
सर यार भी सही सेम जगारो हाइड्रोजन जाकि अल्किन बनना.
समिता, you can annotate. No, तमे जो थिंकिंग प्रोसेस रॉन्ग. नाउ तमे भूली गलो जे लेस हिंडर्ड, सबुठु लेस हिंडर्ड पोजीशन कोठी. तमे एइटा को नहीं गला आगो, किंतु ए जिनस बुझिलेनी एथरे गोटे बीटा एथरे गोटे बीटा प्रोटॉन मिली जिवो, एंड डबल बॉन्ड फॉर्मेशन एटी हेइ जिवो, एंड दिस इज द लीस्ट हिंडर्ड पोजीशन. काहे कि लीस्ट सब्स्टिट्यूटेड अल्किन एटी द गोटे इथाइल सब्स्टिट्यूएंट अछि, एटी द इथिलीन. सो एथरे हॉफमैन अल्किन माने द लीस्ट सब्स्टिट्यूटेड अल्किन. तेणु एइटा अपेक्षा एइटा इथिलीन रे किछि सब्स्टिट्यूशन नाही. So OH minus will be attacking here, this bond will come here, this. So the major pair will be dimethyl seg-butylamine or seg-butyl एटा प्लस इथिलीन. is this pair is the major. मु मना करूनी आरोटा हबनी. Butanine and ethyl trimethyl amine habo. That is the minor I am showing you. You will also have the other one which you were thinking but plus. In this case the amine is this. This is the minor pair. You understood?
Yes, sir.
Sometimes, ring opening happens. Supposing you have N here and you have made it. এটা কিছু নাই, এইটি গোটে CH3 ଅଛି. হিট কল କ'ଣ ହବ? ପୁଣି exhaustive methylation କର, followed by AgOH, followed by heat. କ'ଣ ହବ? So ଦେଖ ଏଇଟା ଗୋଟେ ସାଇକ୍ଲିକ କମ୍ପାଉଣ୍ଡ ରୁ ଆରମ୍ଭ କରିଛି. ପିରିଡିନ୍ ତାକୁ ଦିଥର 2 moles ଦେଇକିରି ତାକୁ ଡାଇମେଥିଲ ପିରିଡିନିୟम OH ମାଇନସ୍ ଏଠି ଅଛି, OH ମାଇନସ୍ ଅଛି, and then I heated it. So first କ'ଣ ପାଇବି? मेजरटा लिख पिया तो रेकर्डिंग हो गीत बोलूँ किए देखुची पिया तो से नेना लगे रे नेना लगे रे ଆମର ସମିନାନୀ ଆମର ଗୋଟେ ହବ ଏଇ ଆମର ଉମ୍, ତମ ଦି ଜଣଙ୍କ ସାଙ୍ଗରେ ଗୋଟେ ପୁଣି ଗୋଟେ ପ୍ରୋଗ୍ରାମ ହବ କଣ ମ୍ୟୁଜିକାଲ ପ୍ରୋଗ୍ରାମ କେତେବେଳେ ତମକୁ ଡକେଇବି ତମ ମମିକୁ କହିବି ଧରିକି ଆସ ଆମେ କେମିତି ସିଧି କେମିତି କହୁଥିଲା ମତେ ଦିଅ ମତେ ଦିଅ ମତେ ଦିଅ କିନ୍ତୁ ଆମେ ଛାଡୁ ନଥିଲେ ତୁମେ ବଜେଇଲ ଗାଇଲ ଆଚ୍ଛା ଏଥର ରିଧିକୁ ବି ଚାନ୍ସ ଦବା ସରି ସିଧିକୁ ତ ଆମେ ଗୋଟେ ପ୍ରୋଗ୍ରାମ କରିବା ମ୍ୟୁଜିକାଲ ପ୍ରୋଗ୍ରାମ କରିବା ମୁଁ ଗୋଟେ ହାରମୋନିୟମ କିଣିଲିଣି ମତେ ସମସ୍ତେ ମୋର ଯୋଉମାନେ ମ୍ୟୁଜିକାଲ ଫ୍ରେଣ୍ଡସ୍ ଅଛନ୍ତି ସେମାନେ ସବୁ କହିଲେ ଆପଣ ଯୋଉ ଗାଉଛନ୍ତି କିବୋର୍ଡରେ ଗୀତ ସହିତ ଗାଆନ୍ତିନି keyboard is not the right it's an instrument supporting instrument interlude ପାଇଁ ଇଏ ପାଇଁ ସେ ପାଇଁ but when a singer sings with some instrument it should be harmonium ତ ମତେ ଏମିତି ଆସିଲା ଯେ I got a harmonium so nowadays I am having my musical videos with harmonium in hand and then singing start କରୁଛି well ତମେ କିନ୍ତୁ ଦି ଭଉଣୀ ଚଲେଇବ କିବୋର୍ଡରେ ଆଉ କାହାର ହେଲା ମ ଏଟା ଗଧା ରେକର୍ଡିଂ ହଉଛି ମୁଁ ଏମିତି କହିଦଉଛି ଛି ଇଏ ଦେଖୁଛୁ ଆମ ଏଇ ଏଇ ଲେଭେଲ ଯାକେ ଦି ପ୍ରକାରର ପିଲା ଯାଇପାରିବେ ଗୋଟେ ପିଲାଙ୍କର ସମୟ ନାହିଁ ଯୋଉମାନେ ଭଲ ଭେରି ଟ୍ୟାଲେଣ୍ଟେଡ ବଟ୍ ଦେ ଡୋଣ୍ଟ ହ୍ୟାଭ୍ ଟାଇମ୍ and they don't know and we don't publish we don't want ଆଉ ଗୋଟେ କ୍ୟାଟେଗୋରୀ ହଉଛି ୟୁ ଯୋଉମାନେ ସଷ୍ଟେନ୍ କରିବେ ଆଣ୍ଡ ଏଇ ଜିନିଷଟା କ'ଣ ମୁଁ ନର୍ମାଲ ବ୍ୟାଚରେ ମୁଁ କହେ କି ଏକ୍ସଟେନ୍ସିଭ ମେକାନିଜମ ଡିସ୍କସନ କରେନି ଯୋଉମାନେ ଆଇଆଇଟି ମାଇଣ୍ଡେଡ ସେଇମାନେ ମତେ ତ ଡର ଲାଗେ ଯୋଉମାନେ ନିଟ୍ ମାଇଣ୍ଡେଡ ଯଦି ବେଶୀ ଥିବେ ମୁଁ ତାଙ୍କୁ କହିଦିଏ ତମେ ବାବା ବସ କି ଯାଅ ଯେତେବେଳେ ଏକ୍ସଟେନ୍ସିଭ ଡିସ୍କସନ ଥିବ ମେକାନିଜମ ଉପରେ ତମେ ହୁଏତ ନା କେତେ ଜଣ ପିଲା ରହନ୍ତି ଆଉ କେତେ ଜଣ ପିଲା ମୁଁ ଯେତେବେଳେ କରୁଥିଲି ଗ୍ରୁପ ବିଦା କରିଦେବି ତମର କିଛି ଇଣ୍ଟରେଷ୍ଟ ଲାଗିବନି କାରଣ ଏଭଳିଆ କୋଶ୍ଚିନ୍ ତ ପଡୁନି ନିଟ୍ରେ ତେଣୁ କାହିଁକି କରିବି ଓ ଜିଜି ମୁଁ କରିବି କି
ସାର୍ ଏଇଠି ଯୋଉ ସିଏସ୍ ଲାଗିଛି ତାର
କୋଉ
ଠିକ
ପଟେ
ଅପୋଜିଟ ସାର୍
ଓ
ସାର୍
ୟା ସମୀ ୟେସ୍ ବିକଜ ଦିସ୍ ଇଜ ଏ ହିଣ୍ଡର୍ଡ ପୋଜିସନ ଗୋଟେ ହାଇଡ୍ରୋଜେନ ଅଛି
ୟେସ୍ ସାର୍
but is more hindered it are less hindered we have to look for a beta hydrogen so ଏଇଠି attack କରିବ so ଏ OH minus ଟା ଏଇଠି attack କରିବ ଇଏ ଏଠିକି ଆସିଲା ଇଏ ଭାଙ୍ଗିଲା so ବର୍ତ୍ତମାନ ସାଇକ୍ଲିକ ଟା ସାଇକ୍ଲିକ ହେଇଗଲା ଏଇଠି ଡବଲ ବଣ୍ଡ ପଡିଲା ଆଉ ଏଇଟା ଭାଙ୍ଗିଗଲା and becomes a tertiary amine ଏଇ ତାର ସେମିତି ଅଛି ହେଲା ଆଉ ୟାକୁ ଯଦି ଏକ୍ସଜଷ୍ଟିଭ ମେଥିଲେସନ କରାଯାଏ 1 ମୋଲ ଏଇଟା ଦରକାର ନାହିଁ 1 ମୋଲ ଏକ୍ସେସ୍ ନେଇକି କିଛି ଲାଭ ନାହିଁ 1 ମୋଲରେ ସେ ହେଇଯିବ ଅଟୋମେଟିକାଲି ସୋ ମିଥାଇଲ ହାଇଡ୍ରାଇଡ୍ ଦେଇଦେଲେ ତା ଫଲୋଡ ବାଇ ସିଲଭର ହାଇଡ୍ରୋକ୍ସାଇଡ୍ ଦେଇଦେଲେ ସିଏ କ'ଣ ହେଇଯିବ ଏଠି ଇଥାଇଲ ହାଇଡ୍ରାଇଡ୍ ଦେଇ ଦଉଛି ଏଠି ଚେଞ୍ଜ କରିଦିଅ ଇଥାଇଲ ଆୟୋଡାଇଡ୍ ସୋ ଦ୍ୟାଟ୍ ଆଉ ଗୋଟେ ମଜା ଜିନିଷ ହବ ଏଥିରେ ତ ଆଉ ବାଟ କିଛି ନାହିଁ ଏଇ ହାଇଡ୍ରୋଜେନଟା ଯିବ ଆଉ ଏଇଟା ତ ଫାଙ୍କା ହେଇଗଲାଣି ତେଣୁ ଦ ଓନ୍ଲି ଚଏସ୍ ଇଜ୍ ଦ୍ୟାଟ୍ ତେଣୁ ମୁଁ ଜାଣିକିରି ଗୋଟେ ଇଥାଇଲ ଦେଇ ଦଉଛି ସୋ ଦ୍ୟାଟ୍ ଏଠି ଇଥାଇଲ ଫସିବ एंड प्लस हाइड्रोक्साइड हो सो बर्तमान कौन कौन दब ଯଦି ଏଇଟା ନଥାନ୍ତା CH3 ଥାନ୍ତା ଆଉ ବାଟ ନାହିଁ। ଏଠି କିନ୍ତୁ ଗୋଟେ ବିଟା ହାଇଡ୍ରୋଜେନ୍ ଅଛି, ଏଠି ଗୋଟେ ବିଟା ହାଇଡ୍ରୋଜେନ୍ ଅଛି, ଆଉ ଏପଟେ ତ ଫାଙ୍କା ହେଇଗଲାଣି, ତେଣୁ ଆଉ କିଛି ନଥିଲେ ବାଧ୍ୟ ହେଇକିରି ଏଇଟା ଆସିଥାନ୍ତା। ଆଉ ଯଦି ନାହିଁ ତାହେଲେ ତ ହବ ହିଁ ହବ। ତେଣୁ ଅବଶ୍ୟ ଛାଡ଼, ବହିରେ ଯୋଉଟା ପଡ଼ିଥିଲା ସେଇଟା CH3 ଥିଲା। CH3 କରିବା, ସେଇଟା କରିବା ଆଉ କ'ଣ। ମାନେ ମୋ କହିବା କଥା, ଯୋଉଠି ହଫମ୍ୟାନ୍ର ପସିବିଲିଟି ଅଛି ହଫମ୍ୟାନ୍ ହବ, ଆଉ ଯୋଉଠି ନାହିଁ କ'ଣ କରାଯିବ। ସୋ ଆକୁ ହିଟ୍ କଲେ ଏଇଟା ଏଠିକି ଆସିବ, ଇଏ ଏଠିକି ଯିବ। ନାଉ ଦେଖ ଟର୍ସେରୀ ଟ୍ରାଇମିଥାଇଲ୍ ଆମିନ୍ ଫ୍ରି ହେଇଗଲା, and you get double bond in both positions. You got it?
Yes, sir.
At this point of time, my EI E1CB SYN ଆମେ ଦେଖିଲେ। Now we'll be talking of substitution versus elimination. That will be the end of our program. আচ্ছা, ଆଉ ଗୋଟେ କେସ୍ ହଉଛି, supposing you are using, I have already told this, supposing you are using this one from alkyl halide, but you want a major product as but1-ene. So who can tell me what base you will take to undertake that?
Sir, after question.
Sec butyl chloride, supposing you treat it with alcoholic KOH, the major product will be but2-ene, minor product will be but1-ene, right? Sajjeb product will dominate over the anti-Sajjeb product. But if you want anti-Sajjeb product or Hoffmann product to dominate,
bulky base नहीं
yes,
tert
yes,
butyl
potassium
potassium.
dot butoxide ion, हो कि नहीं?
Yes, sir.
If you take this K plus TBU minus, then this will not prefer to enter into a hindered position, so it will prefer to enter in this position. Same E2 elimination will occur, but the major product will be the anti-Sajjeb or Hoffmann. So this is nothing to do with Hoffmann exhaustive methylation or heating of quaternary ammonium hydroxide. That is one method. You have to go via amines. But if you want to go via alkyl halide, then you have to take a very strong base. But you cannot do this in primary halide. Primary halide, if you take primary halide, then it will be the substitution product will be the major product. Minor product will be, supposing this one, and then TBUO minus, then it will enter here, ଆରାମରେ ପଶିଯିବ। ଯଦିଓ ଛତା ଭିତରେ ପଶିବା ଟିକେ ଡିଫିକଲ୍ଟ ହେବ, ଏଇଟା ହେବ। So in this case, no, I'm sorry. Major product again will be but1-ene. I am so sorry. ସେଟା ତ ମୁଁ କହିବି ବର୍ତ୍ତମାନ, ଯୋଉ ପଏଣ୍ଟ କରିବି, major product will be but1-ene. Among elimination, minor will be but2-ene, but major but2-ene କିଛି ହବ ନାହିଁ, but1-ene, but there will be some substitution product. This is major. Minor will be the Williamson synthesis of ether, OTBU. That is tert butyl, N-butyl, ether will be minor. So give me some time. I am stopping the pausing. Welcome back. Then we talk about substitution versus elimination. We shall be grouping only in case of alkyl halides. Or like tossylates, which have good living groups. Let us talk only about 3-degree substrates. In SN2, E2, we already know the order we know. But here we will talk only on 3-degree substrate. And there will be two cases. Case 1, use of strong bases like OH minus, OR minus, CN minus, alkynide ion, etc. Even alkyl carbanion, etc. ଏଥିରେ major product ଟା କ'ଣ ହବ? Mechanism ପଛରେ ଲେଖିବା is elimination. 100%. In alcoholic medium ଯଦି ନବ, alcohol medium ନିଆଯାଏ, usually ନିଆଯାଏ, 100% ହେଉଛି elimination and mechanism is E2. Contrary to what people think. And I would like to share my experience. I think I did tell you to tell that. Long ago in 2001, I think when I was there in Ravenshaw University, that time it was college, there was a seminar of PG students. They are doing postgraduate MSc in chemistry and shortly will become teachers. There was a seminar, one girl was presenting a topic on elimination. So she discussed routinely about E1, E2 with examples and all that. Just like a undergraduate student. So I was carefully, observing at that time there was no slide projector. It was all based on transparency projector, transparent seats. Then we put it on a elephant-like looking projector, and then it was projecting. Plastic seat, we're writing transparent seat, we're writing in glass marker, permanent marker pen, and we were getting the projection. So देखिला सरला परे after the end of the seminar, the question answer session, the students are also asked. Any presenter is subjected to answer the questions. If not, others will answer. There will be a healthy discussion on the topic. So after a few questions, maybe there was no question. And the chairperson, the head of the department was at that time was almost going to say, if there is no question, then we will invite the other speaker. Then I raised my hand. I have a question for some girl. I took her name because I used to remember the names and not by title, but by the first names. So I said, please, Miss X, please show me the last slide or the slide in which you showed the elimination of tertiary butyl chloride by alcoholic KOH. Tertiary butyl chloride by alcoholic KOH. So he opened and a very big, because you have to write big, otherwise it will not be projected. I mean, the backbenchers cannot see. So tert butyl chloride is there and ସେଠି alcoholic KOH ଲେଖିଛନ୍ତି and ସେଠି double bond ପକେଇଛନ୍ତି isobutylene ପକେଇଛନ୍ତି କରିଛନ୍ତି and ସେଠି mechanism ଲେଖିଦେଇଛନ୍ତି E1. Do you think the mechanism is E1? C2? I was really surprised. ମୁଁ ତା ପର ବର୍ଷ ଛାଡ଼ିଦେଲି ରେଭେନ୍ସା and took voluntary retirement. I was shocked to find that my colleagues, one of the colleagues who was also guiding, and every student has a guide. One of my colleagues who was guiding, as well as many others who teach organic chemistry, they stared at me thinking probably I am going to harass that girl, to embarrass that girl by asking tough questions. So they wanted to protect her and prevent harassment or embarrassment. But I was not doing that. I was very cool and polite, asking. Then she said, yes, yes, sir. And because it is 3-degree halide, so carbocation is very strong. So it will be E1. Then I asked, are you sure it is E1? ସେଠି ଏମିତି ସେମିତି ଚାହିଁଲା, ଏମିତି ଏମିତି ତା ଟିଚର ମାନଙ୍କୁ ଅନ୍ୟମାନଙ୍କୁ ଚାହିଁଲା. Then all the teachers who were staring at me, the guide had to stand up. He said, ଭାଇ ସେ ସୁଧାଂଶୁ ଭାଇ ବୋଲି ଡାକେ, ସେ ଜୁନିୟର ଟୁ ମି. ସୁଧାଂଶୁ ଭାଇ କ'ଣ ଏଇଟା ତ 3 ଡିଗ୍ରୀ ଆଉ E1 ହବ, ତାକୁ କାହିଁକି ଆଉ ସମସ୍ତେ ସେମିତି ହଉଥାନ୍ତି, ଇଏ କହିଲେ. ମୁଁ କହିଲି ଟିକେ you give a thought. Okay, I'm leaving the class here because it will be spoiling the valuable time. I would speaker ready hegalani. I'm leaving this subject here, but you give a thought, right? सरला ता परदिन मते ए टीचर मानकु सब टीचर ऑर्गेनिक टीचर मानकु डकैली मो रूम को, ताको आको एजुकेट कली. सो 2-3टा फरे नथर बही देखैली, लॉजिक बतैली जे जदि कार्बोकैटायन होता फटकिनी न्यूक्लियोफाइलटा सेठी लागि जीवो, सब्स्टिट्यूशन वुड हैव बीन द मेजर प्रोडक्ट. यार तुम कहूच एलिमिनेशन इज द मेजर प्रोडक्ट एंड 100% कहूच एटा लिखिछ, अथच कहूच E1 ताकू मानकर हाउ आई वाज रियली shocked that if teachers they do not have then after a long time with 2 or 3 books, not Indian book, से सेठू जड़े टीचर मत कहले ना मुखर्जी बुक रे तो एटा अछि बोले आण, से सेठू गले संगे संग टिके आउटरेजियस हेकरी गले मुखर्जी सिंह बही आनिया पे कोठू ना कनिका लाइब्रेरी आनले, आनिकरी देखले खोलले. सी लिखिची कौन, सी बहुत टैक्टफुली डील करछे टर्सरी ब्यूटाल कोलेट नहीं चंदी, किंतु सेथरे अल्कोहलिक केवेज लेखि नांती, किछि लेखि नांती. E1 रो से बुझौचंती, E1 रो बुझौचंती, E1 हेडिंग रे अछि, किंतु आरमार्क ऊपर किछि लेखि नांती कि मेजर की माइनर किछि लेखि नांती, खाली मेकानिज्म बुझौचंती. आइसोब्यूटिलिन E1 रे हबो. मु कहली यस, से तो कोठी अल्कोहलिक केवेज लेखि नांती, कोठी लेखि नांती जे एटी 100% प्रोडक्ट है बोली. तमे जो लिखिछ 100% तो कहिथिलो सेटा तो से कोठी लेखि नांती. से E1 मेकानिज्म बुझौचंती, 100% नो एटा 20% की 15%, एंड एटा माइनर प्रोडक्ट. से विषय E1 जळे बुझौचंती, से गोटे नेले, से किछि एग्जांपल देई नांती कि कंडीशन लेखि नांती. So with dismay they were also surprised. So that's what I'm saying. Okay, I'm spoiling your valuable time. Major product is elimination, that is E2, and the minor product is nothing. I'll write substitution, and that should be E2. But in this case, 0%, almost 0% के बराबर 3 डिग्री में, if you take a strong base. Then if you take a weak base, I'm not giving any example. We have done enough of examples. Weak base like water, alcohol, carboxylic acid, etc. Solvolysis reaction. In that case, the major product is substitution. And that too SN1. Minor product is elimination. This is E1. सेई कथाटा तो एग्जांपल ताकु मु देली, दरी एटा नब वाटर पकेबो, खाली वाटर पकेबो, सेठी अल्कोहल पाइबो. SN1 मेकानिज्म रे मेजर प्रोडक्ट्स रे 80% धर हला टर्ट ब्यूटाइल अल्कोहल, 85% हला, that is SN1 प्लस जो आइसोब्यूटिलिन हब 15% जो है दैट इज E1 कार्बोकेटन हो सारा माने water will compete as a substitute sorry as a nucleophile because it is in abundance quantity solvolysis so tara attacking as a nucleophile with the carbocation will be more so major product will be substitution minor product will be some beta elimination will occur then coming to 1 degree contrast पूरा से वाला
सर
हाँ
के ऊपर
हाँ
शर्ट के ऊपर
हाँ
आठ के शर्ट के ऊपर कुछ यस सर
कौन कौन ହେଲା
नहीं सर ଟିକେ ଲେଖୁଥିଲି यस सर ହେଇଗଲା सर
ମୁଁ ସାରିଦେବି ଇଏ 1 degree ହାଲାଇଟ୍ ଯଦି ଆମେ ନବା ତାହେଲେ use of strong and weak base ଯାହା ତମେ ନିଅ major product ହବ substitution and that is SN2 mostly by strong base କିନ୍ତୁ ଯଦି rearrangement ହେଇଗଲା solvolysis process ରେ then ଏଇଟା bracket ରେ ଲେଖୁଛି SN2 and minor product will be elimination that is E2 ଧର ଗୋଟେ example ଆମେ ନବା N butyl bromide ତାକୁ ଆମେ ଦବା sodium ethoxide এটা 1 degree ଆଖି ବୁଝିକିରି ଆମେ ଲେଖିବାକୁ ପଡିବ 1 degree ରେ ଛତା ଫ୍ରି ଅଛି so the major product will be Williamson synthesis OET but the 10% হব not that beta elimination হবনি হব E2 elimination হব but it will be minor product এইটা যদি হেলানি 90% এটা হেলানি 10% and that is E2 ये ये हला SN2 रे ये हला because they are good strong bases are also strong nucleophiles this is E2 কিন্তু যদি তুমি চাହୁଛ आर केस टू दे चाहुछ सब्स्टिट्यूशन टाको मेजर करियाकू देन तुम नियो स्ट्रांग बेस सॉरी बल्की बेस स्ट्रांग बट बल्की बेस यूज ऑफ स्ट्रांग बट बल्की बेस टट ब्यूटॉक्साइड आयन से कौन हम ना उल्टे ठीक उल्टी जीव एलिमिनेशन विल द मेजर प्रोडक्ट से 1 डिग्री हालाइट रु एटी मेजर प्रोडक्ट हम ये लिखि दउची एलिमिनेशन E2 and minor product हला substitution SN2 so जदि से N butyl chloride रे तमे टॉट butoxide ion नब then you get the major product as but1 and I have the data with me 85% and that is E2 mechanism and some 15% of ether Williamson ether by SN2 CH2 OTBU এটা 50% হব 15 minor product and that is SN2 got it
yes sir
then last but not the least is 2 degree halide how to treat 2 degree substrates ଗୋଟେ କଥା ମନେ ରଖ behaves like 3 degree କିନ୍ତୁ ସେଥିରେ ଯୋଉ ଜିରୋ ହେଇ ଯାଉଥିଲା ଏଠି ଜିରୋ ହବନି मेजर माइनर सेठी जहाँ थिला एटी सेया सेमती केस 1 रे यूज ऑफ स्ट्रॉन्ग बेस सेई OH माइनस OR माइनस थिला CN माइनस अल्काइनाइड आयन एगुड़ा थिला etc. Say major elimination E2, minor substitution SN2. SN2 ଆଉ ଗୋଟେ ହେଲା ୟୁଜ୍ ଅଫ୍ ୱିକ୍ ବେସ୍ ଠିକ୍ ସେଇଭଳିଆ ସଲ୍ଭୋଲିସିସ୍ ସେଠି ବି ସେଇଆ like water, alcohol, etc. Major substitution SN1 and minor elimination E1. ସେଠି ଯାହା ଏଠି ସେଇଆ କିନ୍ତୁ ପରସେଣ୍ଟେଜ ଟିକେ ଏଠି ଚେଞ୍ଜ ହେଇଯିବ ଯୋଉଟା 0 ଥିଲା ତାର କିଛି ମୁଣ୍ଡ ଟେକିବ ସିଏ ଯୋଉଟା 10% ଥିଲା ତା ଟିକେ ବଢିବ ଏଇଟା କଥା ଆଉ ଇମ୍ପୋର୍ଟାଣ୍ଟଲି most importantly use of strong nucleophile but weak base it would additional thing because but a weak base like SH minus like SR minus ଏଗୁଡ଼ାକ ସବୁ soft base they are strong nucleophiles but not strong bases so ଏଇଟାରେ major ହବ substitution and that is SN2 nucleophilicity only refers to SN2 minor nothing ये तो weak base तो କରିପାରିବନି ଆଉ almost elimination product ହବ ନାହିଁ substitution product ଆମେ ତିନିଟା କେସ୍ ଦେଖଉଛି छोट एग्जांपल दौची धर आइसोप्रोपिल ब्रोमिड रे मु तीनटा रिएक्शन कली तुम्हें कौन मेजर नहीं दीटा प्रोडक्ट लिखिबो कोटा मेजर कोटा माइनर लिखिबो गोटे देली इथाइल अल्कोहल A+B आ गोटे देली पोटासियम इथॉक्साइड ना C+D करिया एंड आ गोटे देली सोडियम मिथाइल मर्काप्टाइड मिथाइल थायोलेट सोडियम इथेन थायोलेट कौन हम you are taking a 2 degree मु जानि कि 2 degree substrate पर डिस्कशन करूची it will behave like 3 degree ए दीटा को कॉमन पॉइंट आसी गला एई गोटा एक्स्ट्रा पॉइंट एठी आसीला 3 degree रे जोटा the only product that will be substitution प्रथमे कोन हो A+B कोन हो कोटा मेजर कोटा माइनर
तर मेजर अब होची अल्किन CH3 CH डबल बॉन्ड CH डबल बॉन्ड CH3
कोटा ना 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 हे এটা পাগল এটা টোটাল জিজিটা আরে এটা পুরা উইক বেস সলভোলিসিস রিঅ্যাকশন হবো সলভোলিসিস রে 3 ডিগ্রি রে কোন হবে কোটা মেজর হবে সাবস্টিটিউশন না এলিমিনেশন কোটা মেজর হবে সমিতা अरे 3 डिग्री रे सॉल्वोलिसिस कले वाटर पकेले व्हिच इज द मेजर प्रोडक्ट एंड व्हाट मेकानिज्म
substitution
SN1 मेकानिज्म एठी बी सेया सब्स्टिट्यूशन एठी हबो CH3 CH CH3 OH एटा मेजर माइनर होची प्रोपीन दिस इज SN1 दिस इज E1 काइना वीक बेस अछि सॉरी सॉरी अल्कोहल अछि बरा सॉरी OH हबनी OET एटा त सेया हबो बुझला
yes sir
समिता बुझिलो
Yes, sir.
वीक बेस अछि माने 2 डिग्री टा जेहेतु मु कहिची बिहेव सिमिलर टू 3 डिग्री तेणु सेठी सब्स्टिट्यूशन मेजर प्रोडक्ट हबो SN1 मेकानिज्म रे एलिमिनेशन माइनर प्रोडक्ट हबो बाय E1 मेकानिज्म सो सेटा हला एंड व्हाट अबाउट दिस वन व्हिच इज अ स्ट्रांग बेस तुम जोटा कहउथलो
Yes,
Propene
sir. It.
is the absolute product nearly 100%. And elimination is the minor product. লেখা দিয়েছি মানে এটা মেজর লিখি দিও, এটা নিয়ারলি 100%. ନାଇଁ 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 এটা রিয়েল 100% 3 ডিগ্রি ହେଇଥାନ୍ତା। ଆଇ ଏମ୍ ସୋ ସରି, ମୁଁ ଟିକେ ତରତର ହେଲିଣି। এটা মেজর মেবি 85%। 3 ডিଗ୍ରୀରେ probability factor 9 fold সেই স্টোরি কথা ମୁଁ ଯୋଉ କହୁଥିଲି, ସେଥିପାଇଁ ସେଇଟା 100%। ଏଇଟା মেজর and Williamson synthesisଟା minor। OET ডাইথাইল ইথର will be minor। ଯୋଉଟା 0 ଥିଲା ଏଟା 20% 30% ହବ। and ଏଇଟା କେବଳ ଲାଗିଯିବ ନ୍ୟୁକ୍ଲିଓଫାଇଲଟା ଲାଗିଯିବ SET, ହଁ କି ନାହିଁ?
Yes, sir.
I think we will close today's session। ଆମେ ଶନିବାର ରବିବାର କାଲି ଅଛି, ଆମେ ବସିବା। କୋଉଦିନ ପରୀକ୍ଷାଟା ତ ଫିକ୍ସ କଲନି, ଚୁପ୍ କରି ରହିଯାଉଛ
Sir, Kali.
ସନ୍ଧ୍ୟାରେ।
No,
Sir.
sir.
Yes,
free
sir.
होते हैं।
ସମିଧା is not free tomorrow।
सर
ତମେ
या
କେତେବେଳେ
पर संडे करते हैं। सर
हैं?
या पर संडे।
କାଲି 4th ସଣ୍ଡେ
नो सर, या पर संडे टा।
କରିବା। ହଁ ଠିକ ଅଛି, ତାହେଲେ ମୁଁ ମିଶେଇ ଦଉଛି। ତମେ ସାରି ଦେଇପାରିବ ଇଲେକ୍ଟ୍ରୋକେମିଷ୍ଟ୍ରି, ସାରି ଦେଇପାରିବ ରୁଦ୍ର?
Yes, sir.
ମୁଁ ମୁଁ ତମେ ସାରିପାରିବ?
सर या पर संडे इलेक्ट्रोकेमिस्ट्री हबो।
ମୁଁ କହ ନାଇଁ 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 କାଇନେଟିକ୍ସ ଥିଲା ଗୋଟେ ଗୋଟେ। ମୁଁ କହୁଛି କି ଯଦି ଏତେ ଡେରି ହେଲାଣି କାଇନେଟିକ୍ସ ଇଲେକ୍ଟ୍ରୋକେମିଷ୍ଟ୍ରି ମିଶେଇ ଦେବା କି ନା ନାଇଁ?
सर दीटा को चलियो जा भी करले।
ମିଶେଇ ଦେବା। ତମେ ଏଇ ୱିକରେ ତମେ ଇଲେକ୍ଟ୍ରୋକେମିଷ୍ଟ୍ରି ସାରିବାକୁ ବାଧ୍ୟ ହେଇଯିବ, କାରଣ ତାକୁ ନ ସାରିଲେ ବଡ଼ ଅସୁବିଧା। ଗୋଟେ ତମେ ସେ କ୍ୱେଶ୍ଚିନ୍ଟା ଡିସ୍କସନ୍ ହେଲେ ଥିଲ? ହଁ ଥିଲ ଥିଲ, ୟେସ୍। ସେ ଯୋଉ କଣ୍ଡକ୍ଟାନ୍ସ ଉପରେ ପଚାରିଥିଲା, ଥିଲ ତ ସବିତା? ତମେ ଥିଲ ନା?
नो सर।
ଓ ଯୋଉ କଣ୍ଡକ୍ଟାନ୍ସ ଉପରେ ଆମର ଡିସ୍କସନ୍ ହେଲା, ତମେ ନଥିଲ?
नो सर।
ହଁ, ସେଟା ଗୋଟେ ବହୁତ ଇମ୍ପୋର୍ଟାଣ୍ଟ IIT ର କ୍ୱେଶ୍ଚିନ୍ଟା ସେ ଦେଇଥିଲା। ୱିକ୍ ବେସ୍ ଉପରେ ମୋଲାର କଣ୍ଡକ୍ଟିଭିଟି କେମିତି ଭ୍ୟାରି କରୁଛି ୱିଥ୍ କନସେନ୍ଟ୍ରେସନ୍, ସେଇଟା ଗୋଟେ ଇଣ୍ଟରେଷ୍ଟିଂ ଡେରିଭେସନ୍ଟା ଥିଲା। ସୋ ୱିଥ୍ ଦିସ୍ ୱି ସି ୟୁ ଟୁମୋରୋ। ସୋ ଆମର ପରୀକ୍ଷାଟା କରିଦେବା ଇଲେକ୍ଟ୍ରୋକେମିଷ୍ଟ୍ରି ଆଣ୍ଡ କାଇନେଟିକ୍ସ ଟୁଗେଦର ଅନ୍ 29th 6 PM, right?
Okay, sir.
यस।
Okay. Bye bye. See you tomorrow at 5.
Pranam, sir.
थैंक यू सर।